0 degrees, 90 degrees, 180 degrees, 270 degrees and 360 degrees. So this is the graph of tan x. So if you want cos square x is equal to 1 minus sin square x, or if you want sin square x can be written as 1 minus cos square x. Therefore sin x is minus 4 by 5, cos x is minus 3 by 5, tan and cot are positive, secant x is minus 5 by 3 and cosecant x is minus 5 by 4. That's all. Hello dear students, welcome to this session of mathematics class. I am Mr. Niranjan, faculty, Department of Mathematics, Vidhyaashram PU College, the Temple of Excellence. In my previous class, we have discussed regarding trigonometrical functions and also some trigonometrical identities. Now, based on the trigonometrical functions and the signs of trigonometrical functions, now I am going to take few problems based on those trigonometrical functions. Now, suppose if one trigonometric function is given, and how to find the remaining trigonometrical function depending upon the quadrant, first quadrant, second quadrant, third quadrant and the fourth quadrant. Now, depending upon the signs of trigonometrical functions, we are going to solve these problems. Now, let us come to the first one. Before going to this, let us know regarding the domain. By knowing the domain and range of a trigonometric function, we can solve the problems based on this. Now, here from the definition of sine and cosine function, we might have been observed that they are defined for all real numbers. Sine function and cosine function are defined. They are defined for all real numbers. Further, we observed that for each real value or each real number x, this sin x is lies between minus 1 and plus 1. So, the value of sin x is lies between minus 1 and plus 1, and the value of cos x is also lies between minus 1 and plus 1. So, therefore, the domain of sine function is, the domain of sin x is minus 1 comma 1, and similarly the domain for the cos function is cos x is equal to minus 1 comma 1. So, here the value of sin x lies between minus 1 and plus 1. Similarly, the value of cos x lies between minus 1 and plus 1. Whereas the range for this sin x is, range is from 0 to plus or minus pi by 2. And whereas for this cos x, the range is from 0 to pi. Okay. This is how we are going to find the domain and range for this given trigonometric function. Okay. For sin x, the domain is minus 1 to 1 and the range is from 0 to plus or minus pi by 2. That means this can be written as minus pi by 2 comma plus pi by 2. And whereas for cos x, the domain is minus 1 comma 1 and the range is from 0 to pi. So here for this sin of x, the domain is equal to minus 1 comma 1, and for cos x also the domain is minus 1 comma 1. The closed interval, whereas for sin x the range is from minus pi by 2 to plus pi by 2, and for cos x the range is from 0 comma pi. So these are the range and domain for the simple trigonometrical functions like sin x and cos x. Thus, domain of y is equal to sin x and y is equal to cos x is a set of all real numbers in the range of the interval minus 1 comma 1, where minus 1 less than y less than or equal to 1. So, therefore, this is the domain for the function, trigonometrical function sin x and the cos x. Now, let us discuss the graph of some trigonometric functions. The graph of sin x, cos x, tan x, cot x, secant x and cosecant x. So, here let us come to the first one. The graph of y is equal to sin x. Y is equal to sin x. We know the values of sin 0, sin 0, 0 and sin 90, sin of 90 is equal to 1. So, here the domain for sin is nothing but minus 1 comma 1. The range for this sin is minus pi by 2 comma plus pi by 2. So, here therefore, the value of sin 0 is equal to 0 and sin 90 is equal to 1. So, sin 0 is equal to 0, sin of 90 degrees, sin of 90 is equal to 1, sin of 90. Okay. Similarly, sine of 180 degree, if you come to sine 180 degrees, 180, sine 180 can be written as sine 0, that's equal to 0. Again it comes to 0. So therefore, this is the curve for a sine x. So the graph of sine x is found to be maximum, it oscillates between +1 and -1. The maximum value is +1 and the minimum value is -1. So this is called the sine curve. Okay. Now continuous function. Now let us come to the second curve, y is equal to cos x. Now the graph of y is equal to cos x. So since you know the domain for this cos x is same, -1, 1, whereas the range is from 0 to pi. Now since you know the value of cos 0, cos of 0, sin 0, 0, cos 0 is 1 and cos of 90 degree, cos 90 is equal to 0 and cos of 180 degrees, cos of 180 degree, that is cos pi, that is nothing but -1. So here, hence for cosine curve for cos x, the graph is found to be like this. So when cos 0, for at cos 0, theta is equal to 0, cos 0 is equal to +1. So it will start from this, again goes on decreases. So therefore, this is the cosine curve. So the graph of cos x is found to be start from maximum +1 and goes on decreases as well as increases. Here it starts from 0, goes on increases and decreases. Okay. This is how we are going to write the graph of sin x as well as the cos x. So sine curves and cosine curves. Right. Now let us come to the next one. Next trigonometrical function, that is tan x. You are familiar with this sin x, sine curve as well as a cosine curve. See the difference here, it starts from 0 and here it starts from this maximum value +1. Okay, right. Now let us come to the third type of curve, that is y is equal to tan x. The graph of tan x is found to be, since you know tan of 0, tan 0 is equal to 0 and tan 90, tan of 90 degrees is equal to an infinite value. Okay. Now here this is the curve, x-axis as well as y-axis. Tan 0 is 0 and tan of 90 is equal to an infinite value, goes on increases. This is pi by 2, this is infinite. Again pi, 0, pi by 2, pi, 3 pi by 2 and 270. 0 degrees, 90 degrees, 190 degrees, 270 degrees and 360 degrees. So this is the graph of tan x. So it is 0, tan 0 is 0 and tan of 90 is equal to infinite. This is the graph for y is equal to tan x. Similarly, if you come to y is equal to cot x, y is equal to cot x, you know the value of cot 0, cot of 0 degrees. Since tan 0 is equal to 0, cot 0 is not defined, which is not defined, and similarly cot of 90 degrees, cot of 90 is equal to 0. So if you draw the graph for cotangent function, cot function, this is x-axis and y-axis. Cot of 0 is equal to infinite, cot of 0 is an infinite value and cot of 90 is equal to 0. So this is the graph for a cot, y is equal to cot x, 0, pi by 2, pi, 2, 3 pi by 2 and 2 pi. So you are going to get a graph like this. This is minus pi by 2, minus pi, minus 3 pi by 2 and minus 2 pi, like this. Okay. Now let us come to the next one. Now let us see the graph of secant x, how the graph of secant x resembles. So this is secant x. For secant x, the x-axis, y-axis, secant 0, you know secant 0, secant of 0 is equal to 1 and secant of 90 degrees, secant of 90 degrees is equal to infinite. This is an infinite value. So here the curve is found to be like this for secant x. And similarly, if you come to cosecant x, see how the graph of cosecant x resembles. So this is 0, plus pi by 2, pi by pi, 3 pi by 2, 2 pi, and it is minus pi by 2 and minus pi. The graph of cosecant x is found to be like this. This is the graph of sin x, cos x, tan x, cot x, secant x and cosecant x. Okay. So these are the graph for sin, cos, tan, cot, secant and cosecant x. Now based on these graphs, the distributions of sines, of trigonometrical function. Let me take few examples. Now let us come to an example. First one, this is very simple problem and important problem. Now if cos x is equal to minus 3 by 5 and x lies in the third quadrant, find the value of other 5 trigonometrical functions. Now first, what is given? Given that cos x is equal to minus 3 by 5 and x lies in third quadrant. X lies in third quadrant. So you might have been studied in third quadrant. So here this is first quadrant, 0 to 90, 90 to 180 is the second quadrant, 180 to 270 third quadrant, and fourth quadrant. This is first, second, third and fourth quadrant. So in third quadrant, what is the condition? Tan x and cot x are positive. Tan x and cot x are positive. Remaining trigonometrical ratios are negative. That is just what we have discussed in the previous class. Now cos x is equal to minus 3 by 5. Now if you reciprocate this, secant x is equal to minus 5 by 3. First value you got. Okay, since we know the identity, sin square x plus cos square x is equal to 1. So if you want cos square x is equal to 1 minus sin square x, or if you want sin square x can be written as 1 minus cos square x. Now since cos is given, how to find out sin? Sin square x is equal to 1 minus cos square x. So this is 1 minus 3 by 5 whole square is nothing but 9 by 25. Take LCM, 25 is LCM. 25 minus 9 is equal to 16 by 25. So therefore only sin x is equal to plus or minus 16 by 25 under root is plus or minus 4 by 5. So here, now since x is in third quadrant, therefore sin x is negative. Therefore sin x is equal to, you can take it as minus 4 by 5. Okay. Now what is cosecant x then? Cosecant x is equal to 5 by 4. Cosecant x is also negative here, minus 5 by 4. So cos x is minus 3 by 5, reciprocal of cos x is secant x is minus 5 by 3. Sin x is equal to root of 1 minus cos square, that is 4 by 5. Sin x is equal to minus 4 by 5. Therefore the reciprocal of sin x is cosecant x is equal to minus 5 by 4. So to find tan x is equal to, you know, sin x divided by cos x. What is sin x? Sin x is equal to minus 4 by 5 divided by cos x is equal to minus 3 by 5. So this is minus gets cancelled, 4 by 3. 5 gets cancelled. Cot x, what is cot x? Cot x is nothing but 1 by 10, the reciprocal of this, 3 by 4. So this is how we are going to find the remaining 6 trigonometrical functions. See here, cos x is equal to minus 3 by 5, secant x is equal to minus 5 by 3. Then sin x is equal to 4 by 5, and then cosecant x is equal to minus 5 by 4. Tan x is equal to 4 by 3 and cot x is equal to 3 by 4. This is how we are going to find the remaining 6 trigonometrical functions. Okay. Now let us come to the next problem. What is the problem given? Second, if cot x is equal to minus 5 by 5 and x lies in the second quadrant, find the value of other 5 trigonometrical functions. Same type problem. What is given here? Since given cot x is equal to minus 5 by 12 and x lies in second quadrant. X is in second quadrant. So in second quadrant, what is the condition? In second quadrant, sin theta and cosecant theta are positive, remaining are all negative. So write down the, since cot x is equal to minus 5 by 12 means, therefore the reciprocal of tan x is equal to minus 12 by 5. Okay, now tan and cot is obtained. Now find out sin, cos, secant and cosecant. So we know the identity, since 1 plus tan square x is equal to secant square x. Now 1 plus tan square, 1 plus minus 12 by 5 whole square, that is 144 by 5 is equal to secant square x. Take LCM, secant square x is equal to 5 is the LCM, 5 plus 144. So this is 149 divided by 5. Secant x is equal to square root of 149 by 5. Now let us come to the next problem, problem number 2. What is the problem 2? If cot x is equal to, given that cot x is equal to minus 5 by 12 and x lies in second quadrant. Okay, x lies in second quadrant. Since cot x is equal to minus 5 by 12, therefore tan x is equal to minus 12 by 5. Okay, now since we know the identity, 1 plus tan square x is equal to secant square x. So therefore secant square x can be written as 1 plus tan x. 12 square is 144 divided by 25. Take LCM, 25 is the LCM, 25 plus 144. Secant x is equal to square root of 169 divided by 25. Square root of 169 is plus or minus 13 by 5. So therefore secant x is equal to, since it is in second quadrant, what is positive? Sine and cosecant are positive. Remaining are all negative here. So secant x is negative, we can take this as minus 13 by 5. So secant x is equal to plus or minus 13 by 5. So since secant x in third quadrant is negative, therefore secant x is minus 13 by 5. Okay. Now the reciprocal of secant is cos. Therefore cos x is equal to minus 5 by 13. That's it. Secant x is minus 13 by 5 and cos x is equal to minus 5 by 13. Now find out the sin x. Sin x, since we know sin x can also be written as sin x is equal to tan x into, tan is nothing but sin by cos into cos x. See, sin by cos, cos gets cancelled, we will get the sin x itself. What is tan x? Tan x is equal to minus 12 by 5 into cos x. What is cos x? Minus 5 by 13. Minus 5 by 13. So gets cancelled. Minus into minus plus 12 by 13. Sin x is equal to 12 by 13. Now what is required to find? Sin x, cos x, tan x, cot x, secant x and only the cosecant x. So therefore cosecant of x is equal to the reciprocal of this 13 by 12. So cosecant x is positive, sin x is positive in the second quadrant. Okay. See here. So if cot x is equal to minus 5 by 12, sin x is 12 by 13, cosecant x is 13 by 12 and then tan x is equal to minus 12 by 5, secant x is equal to minus 13 by 5 and cos x is equal to minus 5 by 13. That's it. This is how we are going to find the remaining 5 trigonometrical ratios. Now let's come to the next problem. What is given here? Find the value of sine of 31 pi by 3. So here for this we are going to use the concept of aligned angles. Now what is given? Given sine of 31 pi divided by 3. Okay. So we know that the value of sin x repeats after the interval of 2 pi. For every 2 pi interval, the value of sin x goes on repeats. Since we know that the value of sine repeats for every interval of 2 pi, so therefore this can be written as sine of 31 pi can be written as 10 pi plus pi by 3. Take LCM, see what is LCM? 3 is LCM, 10 into 3 is 30 pi plus pi, that's equal to 31 pi by 3. So sine of 10 pi plus pi by 3. So it will repeats for every interval of 2 pi means 2 pi 10 can be written as 2 into 5 pi. So therefore this is equal to sine of pi by 3. So you know the value of sine of pi by 3. What is sine pi by 3? Sine 60 degrees. Sine 60 is equal to root 3 by 2. Sine 60 is equal to root 3 by 2. Okay, listen to me. The value of sine of 31 pi by 3, 31 pi by 3 can be splitted as 10 pi plus pi by 3, take LCM, 10 into 3 is 30, pi plus pi is 31 pi divided by 3. Since we know this, sine of 10 pi plus theta, sine pi plus theta is equal to sine theta using allied angles. Sine 2 pi plus theta is equal to sine theta. Okay. Now therefore, sine pi by 3 is equal to sine 60, sine 60 is equal to root 3 by 2. Now let us come to the next problem, same type problem. Find the value of cos of minus 1710 degrees. First we know this cos of minus theta is equal to plus cos theta. So here this is the given equation can be written as cos of minus 1710 degrees can be written as cos of 1710 degrees. This 1710 can be written as 1800 minus 90 degrees. 1800 minus 90 is 1710 degrees. 1710 degrees can also be written as this cos as it is 1800 minus 90. So 1800 minus 90 is 1710 degrees. So this can be written as cos of, in terms of radians, this can be written as 10 pi minus pi by 2. So we know the formula again. What is cos 360 minus theta? Cos 360 minus theta is equal to cos theta. So this can be written as cos of pi by 2. That is cos 90. What is cos 90? You know the value of sin 90, sin 91, cos 90 is equal to 0. This is equal to 0. So the simplified answer is 0 for this. That's it. See here, cos of 1000 minus 1710 degrees can be written as cos of minus theta is plus cos theta. We can take a negative sign out. So cos 1710 is nothing but cos of 1800 minus 90. 1800 minus 90 can be written as 10 pi minus pi by 2. Since we know cos 360 minus theta is equal to cos theta, cos of 10 pi minus pi by 2 is nothing but cos theta itself, cos pi by 2. What is cos 90? Cos 90 is equal to 0. That's it. Now let us come to the next exercise. Now let us come to the exercise problems. So same type of problems in the exercise also. Now if cos x is equal to minus 1 by 2, x lies in the third quadrant, find the values of other trigonometrical functions. See here, this can also be solved using like this. What is given? Cos x is equal to minus 1 by 2. Okay, cos x is equal to minus 1 by 2 and x is in third quadrant. X is in third quadrant. In third quadrant, tan x and cot x are positive. Now if you want, you can also simplify like this. Let us represent this in a triangle. So this is an angle x, call it as A, B, C. What is given? Cos x is equal to adjacent by hypotenuse. Find out the value of AB. AB is equal to root of AC square 4 minus 1 is equal to root 3. This is equal to root 3. The remaining 6 trigonometrical functions can be written as cos x is equal to minus 1 by 2. So therefore, the reciprocal of this is secant x is equal to minus 2. Now from the diagram you can write sin x is equal to root 3 by 2. Root 3 by 2 since it is negative. Then the reciprocal of this is cosecant of x. Cosecant of x is equal to minus 2 by root 3. Similarly, you can find out the value of tan x. Tan x is equal to opposite by adjacent. This is root 3 by 1 is equal to root 3. And cot x is equal to 1 by root 3. That's it. These are the remaining 6 trigonometrical functions. Okay. This is the other method to solve the given problem. Or you can use what is given. Cos x is given. You can find out sin x is equal to root of 1 minus cos square x. Then you will get 1 minus 1 by 2 whole square is 1 by 4. You will get root 3 by 2 and simplify. Any method you follow for this. That's it. Now let us come to the next problem. Same, if sin x is equal to 3 by 5 and x lies in the second quadrant, find the values of other trigonometrical functions. What is given? Sin x is equal to 3 by 5. Given sin x is equal to 3 by 5 and x lies in second quadrant. X is in second quadrant. In second quadrant, sin x and the reciprocal of this cosecant x are positive. Okay. Now find out cos x. Cos x is equal to root of 1 minus sin square x. This is root of 25 minus 9 divided by 25. 16 by 25 is equal to 4 by 5. So here sin x is equal to 3 by 5. Therefore, cosecant of x is equal to 5 by 3. So then cos x is equal to 4 by 5. Secant of x is equal to 5 by 4. Then tan x is equal to sin x by cos x. That's equal to sin x. What is sin x? 3 by 5. Cos x is equal to 4 by 5. So this gets cancelled. 3 by 4. And the reciprocal of this cot x is equal to 4 by 3. That's it. So sin is 3 by 5. Cos is 4 by 5. Tan is 3 by 4. Cot is 4 by 3. Secant is 5 by 4 and cosecant x is 5 by 3. That's all. This is the easiest method to solve this problem. But here the signs are very important. So since x lies in the second quadrant, so therefore what are positive values? Sin x and cosecant positive. These are all negative. We are going to get it as negative for this. That's it. So final sin x is 3 by 5, cosecant x is 5 by 3, cos x is minus 4 by 5, secant x is minus 5 by 4 and tan x is minus 3 by 4 and cot x is minus 4 by 3. That's it. Same type. If cot x is equal to 3 by 4 and x lies in the third quadrant, find the value of remaining trigonometrical function. Given, see, given cot x is equal to 3 by 4 and x lies in third quadrant. In third quadrant, what is the condition? Tan x and cot x are positive, remaining are all negative. So let us represent this. This cot x is equal to 3 by 4 is nothing but adjacent side divided by an opposite side. Let us represent this like this. This is an angle x, call it as A, B, C. Adjacent is 3, opposite is 4. Then AC is equal to root of 9 plus 16. This is root 25 is equal to 5. So the 6 trigonometrical functions, 1 by 1. Sin x can be written as 4 by 5. Then cos x is equal to 3 by 5. And the third one, tan x is equal to 4 by 3. Cot x is already given. Cot x is equal to 3 by 4. And secant x is 5 by 3. And cosecant of x 5 by 4. Since here x lies in third quadrant, tan and cot are positive, remaining are all negative. So therefore sin x is minus 4 by 5, cos x is minus 3 by 5, tan and cot are positive, secant x is minus 5 by 3 and cosecant x is minus 5 by 4. That's all. These are the remaining trigonometrical ratios. That's it. Okay. Otherwise, if you want, you can also use this formula, or you can use 1 plus cot square is equal to cosecant square x and simplify using the identity. Okay. Now let us come to the next problem. What is the problem? Same type. If secant x is equal to 13 by 5, x lies in the fourth quadrant, find the value of other trigonometrical functions. What is given? Given that secant of x is equal to 13 by 5 and x lies in the fourth quadrant. In fourth quadrant, x is in fourth quadrant. In fourth quadrant, what is the condition? Cos and the reciprocal of cos is secant. Cos and secant are positive. Now, here same as such, secant x is 13 by 5. We can write cos x is equal to 5 by 13. So, then how to write remaining 4 trigonometrical ratios? You can represent this in a triangle like this, x, a, b and c. What is given? Secant x. Secant x is hypotenuse divided by adjacent side. Find out the value of AB. AB is equal to 13 square, 169 minus 25, that's equal to 144. Square root of 144 is 12. So therefore the remaining 6 trigonometrical functions, sin x can be written as 12 by 13. Then second, cos x. Cos x is equal to 5 by 13. Already it is obtained. Then tan x. Tan x is equal to 12 by 5. Then cot x. Cot x is equal to 5 by 12. Then secant of x. Secant of x is equal to 13 by 5. And cosecant of x. Cosecant of x is 13 by 12. Since it is in fourth quadrant, cos and secant are positive, remaining are all negative. So sin is minus 12 by 13, tan is minus 12 by 5, cot is minus 5 by 12, secant x is minus 13 by 5 and cosecant x is minus 13 divided by 12. These are the remaining 6 trigonometrical functions. Okay. Now let us come to the next problem. If tan x is equal to minus 5 by 12, same type, exercise, these are all exercise, same problems are repeating. So what is given? Given that tan of x is equal to minus 5 by 12 and x lies in second quadrant. X is in second quadrant, sin and the reciprocal of sin is cosecant. These two are positive, remaining are all negative. So let us represent this in a graph like this. Consider positive value, tan is equal to opposite by adjacent. So what is AC? AC is equal to root of 144 plus 25, 169, square root of 169 is 13. Now write down the 6 trigonometrical function. Write down sin x. Sin x is equal to 5 by 13 since this is negative. Cos x. Cos x is equal to 12 by 13. This is also negative. Okay. Sin is positive, cos is negative. And third one, tan x. Tan x is equal to 5 by 12. So tan is negative. Cot x, come to cot x. Cot x is equal to minus 12 by 5. And secant of x. Secant of x is equal to 13 by 12. This is also a negative value. And cosecant of x. Cosecant of x is equal to 13 by 5. See here. 5 by 13, sin x and cosecant x are positive. Remaining are all negative because x is in second quadrant. That's it. Okay. So that's all. This is regarding the problem, that is whenever one trigonometric function is given, to find the remaining trigonometric functions we can use the identities or we can use the triangular relationship to find the remaining trigonometrical functions. So these are the few problems based on the trigonometrical functions depending upon the domain and the range. That's all for today's session. Let us meet with the different concept in the next class. Thank you very much.